Jai Shri Ram friends, most welcome to my channel ConceptHunt. Now today we shall discuss about Law of Motions part 3, which is lecture number 9. Today's agenda is basically number 1, force of friction, in which we shall discuss about force of friction means types of frictions, and then number 2, equations of motion on a rough inclined plane. So these are two topics. Along with this we will be discussing some examples on numericals based on this. Okay. Now see, first of all, what is force of friction? So simple definition is whenever a body moves or tends to move over another body surface, friction force comes into play. Means we can say a force comes into play which acts parallel to the surface of the contact and opposes the relative motion. Just see these two block diagrams, okay, in which I am showing two directions of forces. This is friction of force as per the direction of motion. Okay, this is just opposite. And in second diagram, this is basically the force of friction in the forward direction whenever we are applying the direction of motion in this right to left. Okay, so these are two block diagrams. So basically we are considering a wooden block placed on a horizontal surface and it is given a gentle push. The block slides through a small distance and comes to rest, right? So according to Newton's second law, a retarding force must be acting on the block, right? First of all. Second thing is, this retarding force or opposing force is called frictional force or simply friction force. Okay, so as shown in the diagram, I just told you the force of friction always acts tangential to the surface of in contact and in the direction which is opposite to the direction of relative motion of the body. So these are three important things which you should remember. So this is the basic idea about the friction. Now see, further I'm just explaining this diagram. You can easily see this is the force of friction between the block and the surface, and the direction of motion and this contact surface having the friction in the opposite direction, either of the diagrams, right? So I think this is clear to all of you. Now second is the things which basically govern the frictional force. So means friction between the two bodies depends on number 1, the nature of medium of contact between the two bodies. Means the roughness of the medium increases the friction, number 1. Number 2, normal reaction. What is normal reaction? As normal reaction increases, the interlocking between two surfaces in contact increases because they press harder against each other, so friction increases. So this is about two factors which govern the frictional force. Now what are different types of friction? So there are two types of friction. One is static friction, another is kinetic friction. So let us discuss one by one. The simple definition of static friction is it is a frictional force which comes into existence when one object tends to move over the surface of other object, but the actual force has not yet started. So this is important thing. Okay. Now see further. So one object over another object. This is one thing. Second is this is verge of the movement. Means movement has not been started. And third important thing, it's kind of limiting friction. So we can say if we keep on increasing the applied force to create movement, then a stage comes when the object is on the verge of moving over the other object. So this friction at this time is called limiting friction. Limiting friction is maximum value of static friction. So this you must remember. This is about static friction. Now see what are different laws which govern the static friction. The number 1, which is Fs proportional to normal force, means the force of static friction is proportional to the normal force exerted by other surface normally on the former. Second is Fs is less than equal to mu s into n. Now this static frictional force is given by this Fs less than equal to mu s into n, where mu s is nothing but the coefficient of static friction. Now third law is less than equal to. What is the meaning of this? This is nothing but a sign which generally shows the or represent the adjusting nature of the force of static friction. Then what's the meaning of equality sign? Equality sign in this particular equation shows only when the static frictional force has its maximum value. See, and the final important thing is it is independent of the area of contact between the two surfaces. So these are the laws of static friction. Now see kinetic friction. What is the meaning of kinetic friction and what are the laws? We shall see now, right now. The friction force that comes into existence when one force is actually moving over the surface of other object is called a kinetic or dynamic friction, right? Now see what are different laws which govern the kinetic friction. So we can say the force of kinetic friction is equal or proportional to rather the normal force which presses the two surfaces together. So mathematically we can say that Fk is less than equal to mu k into n, which is mu k is nothing but the coefficient of kinetic friction. And second thing is it is independent of the surface area of contact. And finally third important point is it is independent of the speed of the sliding, provided that the resulting heat does not alter the condition of the surface. So these are three important laws which govern the friction. Now one thing we must remember whenever we study about the kinetic friction, we should know this particular important thing. Just there are basically different blocks A, B, C, D. So if keep it in mind that if more than two blocks are placed one over the other, as in this figure, on a horizontal ground, then normal reaction between the two blocks will be equal to the weight of the blocks over the common surface, right? Now here N1, as I'm showing, N1 is the if suppose N1 is the normal reaction between A and B, which is M into G, because against gravity this is the weight, and N2 suppose normal reaction between B and C. So for B and C, which is nothing but MA plus MB into G and so on. So we can calculate these values. So if the normal reaction we are calculating are more than two blocks, then this concept comes into picture, right? So this is the thing we should remember. Now see friends, another important concept is that of the angle of friction. This is generally being asked in NEET examination. So what is angle of friction? Now the angle which see this diagram first of all. I'm just making in the simple language. There are two forces. One is the force of limiting friction as this mu into n, okay, and another the normal reaction makes with the direction. So these are two forces. One is the force of limiting friction and there is the normal reaction. So the resultant of these two forces obviously this force, this F. Now this force, whatever angle this force makes with the normal reaction lambda, that is called the angle of friction. So finally we can say the angle between which the resultant of the force of limiting friction and the normal reaction makes with the direction of normal reaction is called angle of friction. So this is simple definition. So with the help of this diagram we can easily calculate the angle of friction, that is tan lambda is equal to this mu s into n upon n, means that tan is equal to perpendicular upon base, so you can calculate this mu s. Mu s is basically f upon n, okay. So lambda, you can say lambda is equal to tan inverse mu s, or you can say mu s is equal to tan lambda. So this is the coefficient of static friction, right? So this is the basic idea of this particular friction constant, which is nothing but static friction. So with the help of this equation, we can say that the coefficient of static friction is equal to the tangent of the angle of friction. So this is angle of friction. Now second is angle of repose. What is angle of repose? The minimum angle of inclination of plane with the horizontal at which the body placed on the plane just begins to slide down is known as the angle of repose. As you can see in this diagram, what I'm showing here, there is an inclined plane and this mass is placed over this. So this is about to slide. Okay. Now the minimum angle I'm showing, this I'm saying is minimum angle. So suppose a block of mass m is placed on an inclined plane as in this diagram, whose inclination theta can be increased or decreased. Okay, this can be increased or decreased. So let mu be the coefficient of friction between the block and the plane. So at any angle of inclination, what is normal reaction? So let us see. Normal reaction is equal to n, which is mg into cos theta, right? And what is limiting friction? As you can see from this diagram, limiting friction, the FL is nothing but mu s into n, which is mu s into mg cos theta, right? So the driving force or the pulling force, you can say F is equal to mg sin theta. So this is down the plane. This is down the plane. You must remember this is basically pulling the block in downward direction, right? So what we are observing here, so actually from these three equations, 1, 2 and 3, what we are observing that when theta is increased from 0 to 90 degree, normal reaction n, and hence you can say the limiting friction FL is decreased while the driving force F is increased, right? So there is a critical angle called angle of repose, which is alpha, right? At which these two forces are equal. Now if theta is further increased, then the driving force F becomes more than the limiting friction FL and the block starts to means you can say FL is equal to F, right? At alpha, theta is equal to alpha, what is happening? So this is basically the condition for the angle of repose, right? Now on the basis of this particular condition, we can finally conclude that number one, if theta is less than alpha, then capital F is less than FL and the block is stationary. Second is if theta is equal to alpha, means F is equal to limiting friction, the block is on the verge of sliding, right? And if theta is greater than alpha, then capital F is greater than FL, you can say the block slides down with the acceleration. So these are three important observations on the basis of the relation between theta and alpha, right? Now see, the next topic is equation of motion on a rough inclined plane. So let us discuss about this particular topic. Okay, so this, see, when the body is moving downward, okay, from free body diagram you can easily say, right? Because we are discussing the equation of motion on a rough inclined plane. So R is equal to mg cos theta. We can see from this particular diagram. Okay, this is reaction which is equal to mg cos theta, right? Now what I'm saying, when the body is moving downward due to a acceleration A and the force of friction F between the inclined plane and the body, then what happens? You can say R is equal to mg cos theta. Fine. As the body is moving downward with acceleration A, then the net force in downward direction, which is equal to m into A, right? So you can say this, right? This is m into A. Now what we can say, we know that F is equal to mu into R, right? F is equal to mu into R, which is also equal to mu into R is equal to mg cos into theta, right? So therefore we can say A is equal to what? A is equal to sin theta minus mu into cos theta into g. So this is an important observation, okay? So this is whenever the body is moving downward with the acceleration A. So in that case you can calculate the acceleration, right? Now next thing is when the body is moving upward, right? When the body is moving upward due to a force F applied on its, as in shown, so this is the upward motion. Now in that case what is happening? See, simply from FBD we can say that, see, R is equal to m into g into cos theta, right? In case of downward movement, sorry, upward movement, this is R is equal to mg cos theta, first one. Second is F, you can calculate with the help of force balance equation. F is equal to mg, referring to this figure, F is equal to mg into sin theta plus F. This is equation 2, say. So therefore we can say F is equal to mu into R, that is equal to mu into m into g into cos theta. So this is equation number 3, right? Now what we can say from these three equations, especially equation number 2 and 3, what we can say that F is equal to mg into sin theta plus mu into cos theta, right? or you can say finally acceleration, because we are interested in calculating acceleration. So acceleration comes out to be A is equal to G into sine theta plus mu into cos theta. ओके, तो दिस इज द फाइनल एक्सप्रेशन फॉर एक्सेलेरेशन. तो मैंने इन दोनों केसेस में फॉर फर्स्ट केस एज वेल एज सेकंड केस मींस फॉर अपवर्ड एंड डाउनवर्ड मूवमेंट इन बोथ द केसेस वी हैव कैलकुलेटेड द एक्सेलेरेशन. तो दिस इज एन इंपॉर्टेंट थिंग. तो हियर वन थिंग व्हिच इज टू बी नोटेड स्पेशली इज दैट टू कैलकुलेट द वर्क डन ओवर ए रफ इंक्लाइंड सरफेस एज इन दिस केस मल्टीप्लाई फोर्स विद डिस्टेंस ट्रेवल्ड बाय द बॉडी, दैट इज W इज इक्वल टू FS. ओके, जैसे हम करते हैं ना, W इज इक्वल टू F इंटू S, that is F is equal to M into A into S. So this is for rough inclined surface. Okay, so this is for body moving upwards, and W is equal to MGS in for body moving downward. So in that case you have to calculate the work done in that way. Okay, so this is the second case. So this is about the basic topics which I discussed. So now we shall discuss some drill problems which are based on the topics discussed today. So let us discuss the problems one by one. See, number one drill problem is, suppose a block of mass 1 kg is placed over a rough surface and a horizontal force F is applied on the block as shown in this diagram. Okay, what are the values of force of friction F if the force capital F is gradually increased? You are given this value, mu S is equal to 0.5, mu K is equal to 0.4 and G is equal to 10 meter per second. Means this is static friction coefficient and this is kinetic friction coefficient. Okay, now how to solve this? So simple problem, you just draw the free body diagram. For in order to save time, I have already drawn the free body diagram like this. Okay, now in this particular diagram what we can say, sigma Fy, वही force balance equation use करेंगे हम, sigma Fy is equal to 0. then what it gives me, because I am interested in the force in y direction, तो n minus mg from this diagram, n minus mg is equal to 0, or you can say n is equal to m into g. That comes out to be, m की वैल्यू कितनी है यहाँ पर, m वैल्यू is 1 and g is given as 10, so that is 10 Newton, right? Now FL, what is FL? FL is simply mu s into n, we have just studied mu s into n, so this is simply mu s is given as 0.5 into 10, so this comes out to be 5 Newton, right? Similarly FK, okay, that is mu k into n, so mu k value is given as 0.4 again, and the value of this n is normal reaction is 10, so that is 4 Newton. So this is how we can solve the problem for this particular case. So this is question number 1. Now next question is, this 12 Newton of force required to be applied on a mass 4 kg to slip on B of mass 5 kg. Okay, there are two masses A and B. Okay, find the maximum horizontal force F to be applied on B so that A and B move together. Now see how to solve this problem. Basically, in order to solve this problem, just let us assume mu be the friction coefficient between A and B. Okay. Okay, so friends, I will provide the PDF of this particular presentation in fair form in the description link of this video. Okay, so please check out my video and description link of this, and you get the fair presentation of this PDF, so that it will be easy for you to understand everything, each and everything very clearly. Okay, so okay, so this is the mu, which is the friction coefficient, as 12 Newton. What I'm saying in this particular equation, as 12 Newton force on A is required for slipping. So you can say, see, mu m A into G for A block, mu m A into G is equal to 12, right? This is one thing. Right, simple as per the question requirement. So you can calculate the value of mu. What is the value of mu? Mu comes out to be 12 upon 4 into 10, because these values are given, that is mu comes out to be 0.3. Now for maximum force FB applied on B, now FB maximum force, इसमें कहा है कि maximum force FB is applied on B so that A and B move together, right? Therefore you can say FB is equal to M into A, MA plus MB into A, right? So where you can say A is equal to mu into G, right? Therefore, you can say finally FB is equal to, in this expression, you just put MA plus MB into A की जगह आप रख दीजिए mu into G, so that you are getting the value of FB by putting all these values. So MA is 4 plus this is 5, right? And this is 0.3 into 10. So finally, if you are solving this, you are getting this 5 plus 4, 9, 27 Newton. So this is the answer for this problem. Clear? Now see friends, there is another good question which is like this. In this particular diagram, the coefficient of friction between the wedge of the mass m and the block of mass small m. Okay, there are two things, one is wedge, another is mass. Okay, is mu. The friction between the two is mu. Find the minimum horizontal force required to keep the block stationary with respect to the wedge. Now this problem can be solved with the help of two important things. One is non-inertial frame of reference, another is inertial frame of reference. So let me solve this using, say, non-inertial frame of reference. So how means we are taking the wedge as a reference. Okay, in this case wedge as a reference. Now how to solve this? So first of all, just draw the free body diagram for this. So how to draw the free body diagram? Like this. See this is the free body diagram, because in this is simple weight, okay, and this is the reaction, because I'm using mind you, this is non-inertial frame of reference. I'm using non-inertial frame of reference in this case. Now FBD of m with respect to wedge means real plus one pseudo force I'm using here with respect to wedge. The block is stationary. So mind you, this is non-inertial frame of reference. So this m, which is equal to f mu into n. Okay, then FP is equal to, this is pseudo force, FP is equal to m into a, because I'm using non-inertial frame. So this is n. So this is the final diagram for non-inertial FOR. So therefore we can say now this problem can be easily solved. Sigma fx, you just apply force balance equation. If fx is equal to 0, that is equal to sigma fy, right, in this case. So therefore we can say mg is equal to, this mg is equal to mu into n, right, and also sigma fy is equal to 0. So this gives me n is equal to, this n is equal to, you can say m into a, n is equal to m into a. So therefore we can say using these two expressions, you can say a is equal to g upon mu, and f is equal to what? F is equal to हो जाएगा आपका m plus m, because there are two masses, m into a. Okay, so that is m plus m into g upon mu. Put the value of this. So from this particular expression we can calculate the value. So this is what is required, means you have to calculate find the minimum horizontal force required to keep the block stationary with respect to. So this is the answer. Okay, is equal to small m plus capital M into g upon mu. So this is the final answer, friends. Now see friends, another question which is also an important conceptual question. Let us see, a block of mass m kg rests on an inclined plane at an angle of 30 degree with the horizontal. If the block just begins to slide, then what is the coefficient of static friction between the block and the surface? So for that we have to first draw the diagram, which is the block diagram of this, or rather you can say free body diagram. So I have already drawn this diagram like this. This is the inclined plane as per the question requirement. I have just shown this. This is a block which is about to slide on in either direction, you can say. So in equilibrium, the resultant of these forces must be 0, isn't it? Because we have solved many problems like this. In this case also, we will be solving this using the resultant of these forces, means sigma fx and all those concepts. So in equilibrium, what we say, there's what we can say here, mg into sine theta is equal to f into s, right? Using this expression, first equation, this diagram, and also you can say mg cos theta is equal to n, m into g into cos theta is equal to n. So using these two expressions, using these two equations, you can find out the value of tan theta. Okay, so therefore tan theta is nothing but, I'm just writing fs upon n. Okay, this is tan theta. Now what is the requirement? The block just begins to slide, then what is the coefficient of static friction? Okay, means mu s is to be calculated. So how mu s की वैल्यू मुझे निकालनी है, mu s की वैल्यू क्या होगी? तो उसके लिए हम क्या करेंगे, we would write the equation fs, just a minute, fs is equal to, what is fs? Fs is equal to mu s into n, right? Now in this expression you can say tan theta is equal to mu into s. Okay, using these two equations we can say tan theta is equal to mu s. Therefore we can say mu s is equal to tan, because angle is 30 degree, so you can say this mu s is equal to, simple, mu s is equal to tan 30 is nothing but tan 30 is 1 upon root 3, or you can say 0.577. So this is the answer for the question, right? Now see friends, next question is, a block of wood of 1 kg resting on an inclined plane of angle 30 degree just starts moving down. If the coefficient of friction is 0.2, then find its velocity in meter per second after 5 seconds. Take g is equal to 10 meter per second square. Okay, now these as per these variable parameters given, I am just showing this block diagram of this particular question. So acceleration of block down the plane is given by, how to calculate this? For the motion of the body along the inclined plane, how to write a? Okay, a, how to calculate a? A is nothing but, see this, a is equal to mg into sine theta, because I've already discussed this in inclined plane section. Okay, just 10 minutes before I discussed all this expression. So a is equal to mg sine theta minus mu into mg into cos theta upon m. Okay, as r is equal to mg cos theta and f is equal, यहाँ पे देख लीजिए, as r की वैल्यू क्या है, r is equal to mg cos थीटा है, एंड व्हाट इज द वैल्यू एफ एस की वैल्यू यहाँ पर है म्यू इंटू आर. तो इन वैल्यूज को यूज करके मैंने जो आपको लास्ट स्लाइड्स में कुछ डेरिवेशन बताए थे इंक्लाइन प्लेन के लिए, सो आई एम यूजिंग दैट एक्सप्रेशन ओनली. तो यूजिंग दिस एक्सप्रेशन ओनली आई कैन यूज और आई सॉल्व माई प्रॉब्लम. सो व्हाट इज द वैल्यू ऑफ ए फाइनली, आई एम इंटरेस्टेड इन द वैल्यू ऑफ ए. तो ए इज इक्वल टू, यू जस्ट पुट ऑल दीज वैल्यू. सो ए इज 10 बिकॉज एम इज इक्वल टू 10 इन दिस केस. एम की वैल्यू कितना है यहाँ पर, सॉरी एम इज गिवन एज g, sorry, m is equal to 1 and g is equal to 10. So 10 into sin theta is sin 30 degree, right, as per this question requirement. Theta is 30 degree, right, and this minus mu is given as 0.2. putting all these values, simply 10 into cos of 30 degree, right, because all these values are given in the question. So finally we are getting a is equal to 10 sin 30. So I'm just writing the values directly. 10 into 1 by 2 minus 2 into ये 0.2 into 10 is 2 into cos 30 is root 3 by 2. So if you are solving this expression, you are getting simply 3.268 meter per second square. So this is acceleration. So from the first equation of motion, अब देखिए यहाँ पर हमें क्या चाहिए, वेलोसिटी चाहिए. तो फॉर कैलकुलेटिंग द वेलोसिटी यू जस्ट राइट द इक्वेशन ऑफ मोशन विच इज u इज इक्वल टू u minus at because there is a retardation. Okay, तो वेलोसिटी आफ्टर 5 सेकंड you can calculate. तो means v is equal to u is nothing but 0 plus 3.6268 दैट इज ए इंटू 5 सेकंड के बाद आपको कैलकुलेट करना है. तो यहाँ आंसर आएगा, हम जस्ट राइटिंग 16.34 मीटर पर सेकंड. तो दिस इज द आंसर फॉर वेलोसिटी विच इज आफ्टर 5 सेकंड्स. ओके, तो दिस इज द आंसर फॉर द क्वेश्चन, राइट. Now next, another important problem, just discuss this question is a 4 meter long ladder weighing 25 kg rests with its upper end against a smooth wall and lower end on rough ground. What should be the minimum coefficient of friction between the ground and the ladder for it to be inclined at 60 degree with the horizontal without slipping? Take g is equal to 10 meter per second square. Okay, so this is the diagram given in this. All these values are given. For example, this 60 degree, 30 degree. So in this program, what I'm showing, AB is a ladder of weight W which acts at its center of gravity like this. Okay, next is important thing is see this angle ABC, this 60 degree and this is 30 degree. Okay, so let N1, this what is this N1? N1 be the reaction of ball and the N2 is this is the reaction of the ground, right. Force of friction F यहाँ पर शो किया गया है, F between the ladder and the ground acts along BC. Okay, this is the force of friction. So for horizontal equilibrium we have to consider and for vertical equilibrium. So let us write the equations for horizontal equilibrium and vertical equilibrium. So for horizontal, okay, horizontal equilibrium, what is the equation for horizontal equilibrium? I'm getting equation like F is equal to N1, right, simple equation. And for vertical equilibrium, what is the equation for vertical equilibrium? The equation would be N2 is equal to W, right? N2 is equal to W, right? So these are two important equations which govern the solution. Now taking moments about B, we get for equilibrium. तो अब यहाँ पर अगर B के अबाउट अगर मैं मूवमेंट कैलकुलेट करता हूँ तो मेरा इक्विलिब्रियम के लिए कंडीशन है. हाउ टू कैलकुलेट दैट मूवमेंट? N1 अगर हम इफ यू आर कैलकुलेटिंग विद रिस्पेक्ट टू B, तो व्हाट इज द इक्वेशन? N1 into what is the component of this reaction? That is 4 into this angle is 30 degree. So 4 into 30 degree into N. Okay, this is the moment minus what is the weight? This W into this 2 into cos of 60 degree, right? 2 into cos of 60 degree. This N1 into 4 cos 30 minus W into 2 of cos 30. I think it is correct. There is no mistake in this. N1 4 cos 30 minus W. W is the weight and this is the component 2 cos 60 which makes it 0. Okay, so this is equation number 3. Okay, so here what is the value of W? So W is equal to what is W here? This is basically 25 kilogram and 10 this. So W is equal to M into G. So 25 into 10, that is basically 250 Newton. Okay, this is 250 Newton, right. Now solving these three equations 1, 2, 3, what we are getting? We are getting the value of F. First of all, what is the value of F? If you are getting this solution, so let me pause this video, just mind calculating so that I would get you the video solution. Just wait, I'm just solving this using calculator so that the time would be less time we will require. Okay, so this is now F2 comes out to be 72.2 newtons and N2 I'm getting is 250 Newton, around 250 Newton. Okay, now with the help of these two you can easily get the friction value, means coefficient. हमें वही चाहिए ना, यहाँ पर friction between the ground and the ladder. What is the value of mu? तो mu is equal to F upon N2 की मदद से you can calculate the value of this mu. तो this comes out to be simply F is 72.2 and this value is 250. So using these two values I'm getting the answer as 0. Okay, just this would be 0.29. करीब this would be approximately 3. So mu comes out to be approximately 3. So this is the answer for this question. So दोस्तों friends, this is the video for today. Okay, so I think I've discussed all the things in detail. If there is any problem you can comment in the feedback. So in next video I would be discussing many PYQs for this laws of motion. Okay, so after that I shall start next topic. So thank you for watching this video. आप लोगों का दिन शुभ हो and जय श्री सीताराम जी.